Hello and welcome to my tutorial on enthalpy. Now, enthalpy is the heat content stored in a chemical system. It's stored as chemical energy, or the energy stored in chemical bonds formed when two or more atoms bond together. Now, the heat gained in the chemical system in heat loss is heat loss from the surroundings. Heat loss is a chemical system, and heat is gained to the surroundings. Now, the surroundings of what is basically what is outside of your reaction vessel or the chemical system. The chemical system is just reactants and products, and you can find out the amount of heat exchange between the chemical system and the surroundings. So enthalpy is basically the heat content in a chemical system, H we usually call it, and exothermic refers to a reaction in the enthalpy of the products is smaller than of the enthalpy of the reactants, resulting in a heat loss to the surroundings. So, what is energy? Chemical energy is a form of potential energy that lies between chemical bonds. So they're the forces of the attraction that bind atoms together in compounds. When the chemicals form new substances, the bonds will break and new bonds form as the products are made. So it's called chemical energy between the atoms when this takes place. And if you look at this diagram here, an exothermic reaction can be summarized as the negative change from energy state of the reactions to energy state of the products. So this is also known as the delta H, or the products heat content minus the reactants heat content. But we'll talk more about that after I've talked about exothermic and so endothermic reactions. Endothermic are the opposite, in which the enthalpy of the products is greater than the enthalpy of the reactants, so there's heat being taken in from the surroundings. This is outside of the reactants and the products, so this would be known as delta H positive. And the reactants increase energy when they become products. So whenever you draw a diagram like this, you have progress of reaction, and enthalpy along the side. Enthalpy and energy are the same thing. However, the Exocio example would like you to use the term enthalpy, as it's a lot easier to understand in exam questions, because they will only use the word enthalpy really. Yeah. So we look at the equation. Delta H is the H of products minus the H of the reactants. So if we look at enthalpy change, in some reactions the products of the reaction have more chemical energy than the reactants. In others, products have less chemical energy than the reactants. So enthalpy change delta H is when the heat exchange with the surroundings during a chemical reaction at constant pressure and the difference between the enthalpy of products and enthalpy of the reactions is this formula. So generally all chemical reactions either release heat, exothermic reactions, or absorb heat, endothermic reactions. Now if you have a look at this one, this is a heating reaction, or an exothermic reaction, and the formation of calcium hydroxide can produce heat, and that's how apparently self-heated cans are used in the war. So self-cooling cans have the opposite effect. They cool down beer. So let's have a quick look at the diagram. So the cooling gel, it just cools the beer down. to a reasonable temperature, so you can enjoy it. So, in an endothermic reaction, the enthalpy of all the products is greater than enthalpy of the reactants, and there is a heat gain to the chemical system from the surroundings. Delta H is a positive sign because heat has been gained by the chemical system, and an endothermic enthalpy change is shown below, which is what we had a look at. So to summarise, reactants go to products, positive, that's endothermic reaction. So the enthalpy of the product is greater than the enthalpy of the reactants, resulting in heat being taken in from the surroundings. And for exothermic, it's the opposite. Heat is to the surroundings. And here's another graph, because graphs are cool. Reactants go down to products. And that's it for this tutorial. I hope you enjoyed it. Leave a comment in the comment section below, and I'll see you next time.